Well, it's a tale as old as time. The network industry has a need, and in our case, that need would be gateway redundancy. And so the industry standards world can take a while to come up with a solution. And so what we have is we have vendor solutions, and especially Cisco very oftentimes steps in and says, hey, we have a solution. In this case, it was HSRP, and this was the original HSRP version 1. Well, eventually, the industry did catch up and said, hey, we also have a solution because Cisco proprietary protocols can only go on Cisco devices. And so if I have two non-Cisco routers, I can't use HSRP here. I would need something that is allowed to be deployed because Cisco owns the rights to HSRP. So instead, the industry created the Virtual Router Redundancy Protocol, or VRRP. Now, by all rights, VRRP and HSRP, they are very similar. They're going to operate very similarly, and even the configuration can be pretty similar. But the industry does like to differentiate themselves a little bit from what Cisco creates, and so we do have a few differences, and there's actually one pretty compelling difference with VRRP that might even entice us to use VRRP instead of HSRP. And to be clear, Cisco devices, so if we get a Cisco router or a Cisco layer 3 switch, we can choose HSRP version 1 and version 2. We should always choose version 2, or we can choose VRRP. Cisco does allow us to deploy that, which is important because we might have a Cisco device and a non-Cisco device that are on the same network, and we want to be able to run a protocol between them for gateway redundancy. At that point, it would require us to run VRRP. So Cisco does play nice and deploys their own protocols alongside the industry standard ones. And I will say this, in many cases when this happens, the Cisco version of a protocol goes away. We think back all the way to when trunking was performed via Cisco's interswitch link, or ISL protocol. They were the first ones to create the means for trunking between switches. The industry eventually created 802.1q, or what we sometimes refer to as .1q trunking, and that's great and all. So Cisco supported both for a long time. Well, eventually ISL disappeared. Even on Cisco devices these days, we can't run ISL, and so we might have expected HSRP to eventually disappear as well. I'd say the opposite has happened. With Cisco networks, when we're deploying all Cisco, we typically see HSRP. It's just the protocol that a lot of Cisco engineers are comfortable with. When I say Cisco engineers, I mean you and I, people who don't work for Cisco, but we're deploying Cisco technologies. A lot of times we say, okay, well, HSRP is pretty simple. I understand it. I can configure it, and therefore I'm good, and I don't need VRRP. And if I'm running a fully Cisco network, there's no problem with that. And in fact, that's what we see a lot of today. But naturally, we also need to know and understand VRRP in order to be complete network engineers, because guess what? There's going to be a day where we have to support either this topology or just flat out a non-Cisco network that is running VRRP instead of HSRP. Now, again, we do have a lot of similarities between HSRP and VRRP, and so for the most part, we want to focus on the differences, because we understand that there's going to be a node that is operating the virtual IP address, and then that node can fail and the other one takes over. A lot of that initial FHRP conversation is going to hold true for both protocols. So let's focus on the differences from HSRP. So first of all, we do have new terminology. Instead of active and standby, we are going to have master and backup. These are the roles that we use for VRRP. Furthermore, if we have lots of routers in this network, before we had the listen role for HSRP, but here we're just going to have many backup roles. So if I have 4 routers that are all part of this domain, one will be the master, the other 3 will all be backup routers. Next, we have to elect a master, and we're still going to use the priority concept, although interestingly, at least on Cisco devices, our priority is going to range from 1 to 254. So remember, we had the full 8-bit range, 0 to 255 with HSRP. With VRRP, it's going to be between 1 and 254. We do have one reason for that, and we'll see that here coming up, where the priority of 255 is reserved. and actually utilized, whereas 0 is also reserved. It's just not actually part of the framework at this time. So next we have timers. Same concept. We're going to send our packets at a particular hello rate, and we're going to recognize that there's an outage after the hold timer expires, except in our case here, the default timers are different. It's going to be 1 second hello timers and 3 second hold timers, meaning that we'll detect an outage a whole lot faster with VRRP if we use the default timers. Furthermore, and this is an interesting thing, preemption, that same concept applies here, but it's actually enabled by default. Just kind of an interesting configuration change from HSRP. If we don't want the failover to fall back to the original active, then we don't do anything to the HSRP config, but for VRRP, we actually have to disable it since it's enabled by default. Lastly, authentication does still exist. Although on Cisco devices, we actually only support open authentication, which is kind of interesting. So that means that we have plain text passwords that are sent back and forth, which doesn't help prevent the bad guys from breaking into our network, but it does make it so we don't have accidental misconfigurations, meaning that I've got multiple maybe VRRP groups on here, and so I can authenticate with one password on these two, authenticate with a different password on these two, and that way it's less likely to accidentally cross our VRRP streams, so to speak. Now next we do need to talk about the addresses that are used. From a multicast perspective, VRRP is going to have its own reserved address of 224.0.0.18. So unlike HSRP version 1, which started with the all routers address, VRRP does have its own IP or MAC address, multicast address from the beginning. And it also does have its own virtual MAC address range, just like with HSRP. And this one is going to be 0000.5E. And then from here we have 0001XX, meaning that these last two are going to be based on the group ID. Now, just like we talked about before, the fact that we have 2 hex characters means that we're going to have a total of 256 groups. And this doesn't change with different versions of VRRP. We're going to be locked to 256 groups, meaning that if we do have that conversation we said, if we have VLAN 500, for example, we're going to have to match that up with group ID of 17, something probably pretty random, and we can do our best to associate it. Again, maybe 50 is available, but ultimately we are not able to lock in our group ID to match our VLAN ID using VRRP. Now, lastly, we have one other really nifty feature that VRRP has that HSRP doesn't, and that is that we can use a physical address as our virtual address. This is very interesting. And first of all, let's describe exactly what we're talking about, and then we can explain why it matters. So let's say that we have a pair of routers, and we have these layer 3 interfaces that are connected to a broadcast domain, a VLAN. So we'll just say this is VLAN 100. And if we wanted to configure this via HSRP or with VRRP the traditional way, we would have a virtual IP address shared, and therefore we'd have something like that .253 on the left, .254 on the right, and .252, I guess, up here. I meant to start with 252, but we have 3 IP addresses in use here. Well, we do have an option that we could use that changes this up a little bit. We could point to one of these physical addresses and say this is our virtual IP address. Now, it's no longer virtual, it's a physical address. But here's what's interesting about this. I'm going to set my default gateway to whatever that IP address is. So let's say it's .253 we'd said before. So my default gateway points to 253. I'm still going to configure this router with its own IP address of .254. And so if we think about this, this is interesting because now I'm going to be pointing to this IP address, and if this device were to go down, I just lost access to my gateway. I lost access to 253. except if I'm running VRRP here, and I specify that this virtual address is .253, then that still allows me to have my master. It allows me to have my backup. And in the event that this interface goes down, this device can take over for 253. Pretty interesting. We're not specifying a third IP address here. We're just taking advantage or making use of the IP address that's already configured on the router on the left. So that's kind of cool. Now, there's a couple of things to note about this. First and foremost is preemption. Preemption is not only must be enabled, it also requires that we keep the device that owns the IP address, that has to be the master. Which makes sense, because if this device comes back online, I could try to have preemption disabled, but I own .253. I must fail back to the original master node because it needs to be online with the physical IP address. So I would shut down my operations of .253 here on the right and defer to the original master. So we have no choice about that. Second of all, that priority value that we mentioned, it's going to be locked to 255 for this node. Again, ensuring that it is the master. So long story short here, that master device, the device that owns that physical address, must be the master, and it must always be the master if it's online, meaning if it goes offline, it has to preempt when it comes back online. And that's just, again, the nature of running with the physical IP address. If it's online, it has to have ownership of it. Now, then we have to ask the question of why. Why would we go to all of this trouble to have this feature? If we have a /24 subnet range, we've got 256 addresses, 254 usable, and if I'm going to use 3 of those for my gateways, then I still have 251 addresses. Not a big deal. There's probably not a compelling reason for us to do this with a /24. But now think about something much smaller. Well, let's think about a /29. A /29 has 8 addresses and only 6 usable. And now let's imagine that this isn't a laptop connecting in. Let's imagine this is another layer 3 device that is pointing up to a gateway, maybe some kind of internet edge topology. So now we have a scenario where we only have 6 usable, and I'm going to want to maximize my space. If I'm using 3 of those for VRRP, that only leaves me with 3 left, one of which, by the way, needs to go right here. So if I'm trying to perform any NAT type of operations, my IP address usage is limited. Meanwhile, if I only use 2 for VRRP, well, that increases it by an entire IP address. And even though it's only 1 address, percentage-wise, that's actually pretty good. And it gives me 1 more address that I can use for whatever it is that I need to use it. Maybe it's other devices, maybe it's NAT like I mentioned. But either way, this concept here, where we have a very limited number of IP addresses, and we're using a first-hop redundancy protocol in order to facilitate gateway operations, well, at that point, we very well might need to rely on this physical address concept, which would lead us to turn off HSRP, if that was our plan, or that's what we had running, and enable VRRP to recover that IP address and be able to leverage it fully. But at the end of this conversation, we see that outside of this specific scenario, VRRP operation is very similar to HSRP. We just have to understand the new address format, and we have to understand that configuration-wise, there are going to be differences and a little bit of difference in terminology when compared to HSRP.
Thanks for watching. Be sure to click here to subscribe to CBT Nuggets and click the notification bell to make sure that you're aware of every time we post new content. If you're interested in a career in IT or you want to brush up on your IT skills, then swing over to our website, and while you're there, be sure to sign up for a free trial.